All right, today we're talking about rotations. This is usually the hardest one for people to grasp, to accurately move points on a coordinate plane. So this video will be a little longer than usual. Okay, the basic idea is to rotate anything, a point, an image around a point. You need two specifics. Okay, first, you need to have a center point to rotate around. I like to think about this like putting a point in a piece of paper, like taking a piece of paper, putting it on a wall, sticking a thumbtack through a part of that paper and rotating it around. Now notice I could rotate this around this left side. I'm putting my left finger down, I'm moving my right finger, or I could keep my right finger right over here and rotate it this way. So I could rotate around any point I want, in fact, okay? So just to reiterate that, this time I'm going to put my finger in the middle of this and I'm going to spin it around the middle. So I can rotate this around any point that I want. This time I'm going to put my point way off to the left and I'm going to rotate it right around the edge of the left side. See, I can rotate it around there. So the very first thing you need is a center of rotation. The second thing you need is you need an angle. Now, also you need a direction. When we get past geometry, we just talk about this in terms of positive or negative sign being the direction. In this class, we'll talk about it in terms of clockwise or counterclockwise. Okay, so rotate 90 degrees clockwise. Let's say I'm rotating around that number 2. So around this number 2 right here, I'm going to rotate this set of instructions 90 degrees clockwise. So what that's going to do is that's going to take my top line that was horizontal, and now my top line is going to be pointed down. Now because of the size of the screen, it actually is shrinking a little bit here. But if I was rotating, well, let's start small. Okay, if I'm rotating at 90 degrees, the words were horizontal. Now I spin 90 degrees, and those words that were horizontal 90 degrees later are vertical. That's a 90-degree turn from horizontal to vertical, horizontal to vertical, and this is in the clockwise direction, just like the fingers of a clock move around. Okay, so the two things you need are a point to rotate around, because again, I could have rotated this 90 degrees around the right side, so it would be, if I put my finger over here by the word, rotate, and spin around this as my center point, well then this whole thing now is more like it's pointing at the 9 on a clock, and it will go up until it's pointing at the 12. So I'm going to shrink it a little bit so I can fit. So if it was pointing at the 9, I spin 90 degrees, and now it's pointing at the 12. So starting here, I go tick-tock, clockwise up to the 12, and that's my rotation around the word rotate. Okay. So let's actually just sketch out some examples here. So rotate this triangle about the point A or around the point A. So point A is my center, and the thing I'm rotating is this triangle, okay? So let's see if I could do that visually. Let's paste it right on top of itself. So what I'm gonna do, oh, that's not gonna work, okay. Well, let's just do it this way, okay? So I'm gonna take this whole thing, and I'm gonna put my finger right on the point A, and I'm going to rotate it around, whoop, 180, right? So my finger started over, one finger's on point A, the other's on the image, and I'm going to spin it until my finger is on top, that's 90 degrees, and then another 90, it's over here. So that's a 180-degree rotation. Okay, now notice I didn't say a direction for this rotation. 180 degrees, it doesn't matter whether you go counterclockwise or clockwise, you still end up in the same spot. So just to sketch this, this will look something like, maybe like that. Okay, maybe thinking of it like it's a flag on a pole and it spins 180 degrees, and so now the flag on a pole is pointing down. Okay, now the face, I'm going to do this a little differently. I'm going to do this without visually moving it. So I'm going to think the center of this face is here, and it's about this distance from C. So what I'm going to do is I'm going to spin that stick. And this says 90 degrees counterclockwise, so against a clock. So I'm going to spin this 90 degrees and get a perpendicular. So this looks about perpendicular to that original. It's a 90-degree angle. So I'm going to spin it over here. And it's going to stay the same length. So as I spin it around, it's going to end up somewhere over here. So that's the center of my face. That's kind of half the battle. And now the next thing is, which way is it pointing? I like to think about this like I use my hand with my thumb sticking up and my elbow being the center of rotation, and I kind of swing my arm. And so my my thumb is sticking up like where his hair is, and I kind of start swinging this down and over, and yeah, it's kind of hard to arch your arm like that. But what we get is, as he's rotating, I'm drawing it smaller than it would be, but the hair is maybe a little bit more like this. Actually, that was a bad job. Let's do it. The hair is actually a little bit more like this as he starts rotating. As he rotates more, it's a little more like this. And finally, the hair should be rotated 90 degrees and should be facing like that. And the smile and the eyes. That's a sketch of what it looked like. Now, that's not perfect, but there will be some problems that say sketch. And I'm not looking for artistic ability. I'm looking at more accuracy of, one, location. So where did it swing to and end up? And two, orientation. Which way is the shape pointing? If it's a little off in scale or perfection, that's okay. But one is, where is it located? So that's that 90-degree spin, still being about the same distance away. And the second thing is, which way is it facing? So the face was pointed up this way, so when I swing it backwards, it should be now pointed this way. Okay. Beyond that, the art isn't as important. Okay. So how do we actually move a point accurately? Not just I want to sketch it, but how do I move it accurately from one place to another? So I'm going to walk you through the directions, and then I've written them out here, so I'll go over them with you. But just to talk you through it, this is the way I do it. Now, different people do it differently. That's totally okay. I've heard at least 3 great versions from students. So I think about, I'm rotating around the origin. That's a fancy word for 0, 0. Okay, I'm going 90 degrees clockwise with point A. So the way I think about it is because I do some programming in my other class, I think about like I'm programming a robot to get to A. I'm going to start the robot pointed down, and I'm going to tell it move 5 spaces, okay? So move 5 if you start pointed down. And then I'm going to tell it, if you're traveling down, and this is hard, like imagine yourself walking down this thing, you're facing down, you're facing in this direction, you are going to make a left turn and go over 2. Okay, so I'll start the robot pointing down, and then I'll say, go. He'll walk forward 5, make a 90-degree left turn, and walk forward 2. That's the path. So now what I do is, once I have that path established, and this could be any path. I could have gone over this way. I could have zigzagged a bunch to get there. It doesn't matter the path, but I'm just trying to pick the easiest one. Now all you need to do is say, okay, well, let's rotate that starting position of the path 90 degrees clockwise. So like a clock, I was pointed down at 6. That's where my robot started. Instead, I'm going to start my robot now pointing 90 degrees over at 9. And I'm going to follow the exact same instruction. So I'm going to say, robot, now that you're starting in that direction, I'm going to say walk 5 or drive or whatever, 5. Make a, and let's look back, we made a left turn. So then left turn and go 2. And you end up at this point. There's A prime. Okay, let's just try that with my little scissors here. I'm going to cut out this, and I'm going to say, okay, I'm going to put my finger on that center point, and I'm going to rotate this 90 degrees. So, hey, that's good, 90. So we started here, ended up here. Started here, 90 degrees later, okay? So, another way to do this is kind of sketch it out a little bit. So, if you have that starting path as an L like this and you want to change it, then you go, okay, well, my L will swing a little bit and be looking like this. Then it'll swing a little bit more, swing a little bit more, swing a little bit more until I've got a 90-degree angle here from my start to my finish. My L is still oriented in the same like direction, clockwise or counterclockwise. It was pointed down like in the counterclockwise direction. So as I rotate it, still that tail is in the anti-clockwise direction. So that's another way to kind of spin your L, and it keeps going and it keeps going like that. That's a 180-degree rotation. More. That's a 270-degree. And I know, yes, this is a similarity to a swastika. Let's get beyond that with the maturity. Okay, then we go there, we go there, we go there, and we're back to a 360-degree rotation. So that's another way to kind of sketch it out as you're going through. Okay, so let's do another one. Okay, so this one, the difference here is we're going about the center point 1, 2. So that's C. C is our center point. So if I spin C around itself, it's just in the middle spinning, so it actually ends up right where it's at. So C prime stays where it's at. Okay, but what about A? So this is the way I do it. I go, okay, I'm thinking of any path. I'm going to say go up 3, make a right turn, and then go 3. Okay, so I'm going to spin that path 180 degrees. So instead of starting my robot facing up, I'm going to start it facing down. So I'm going to say go down 3, and then make a right turn. So if I'm going down, a right turn would be like this, and then go 3. Okay, so my new shape over here, let's do it in purple. My new shape will be here at C prime over, so 1, 2, 3, 1, 2, 3. Here would be A prime. And then I'm going to do the same thing with B. I'm going to say my path for B is I'm going to start facing right. I'm going to go 4, make a left turn, and go 1. Okay, so I'm going to spin that 180 degrees. So instead of starting facing right, I'm going to start facing 180 degree difference. I'm going to start facing left. So I'm going to go 1, 2, 3, 4. And which way do I turn? Looking at my original, if I was walking, I made a left turn. I'm just, to notice that, I'm saying right here. If I was walking down a path, putting myself in those shoes, I made a walking left turn. Okay? All right, so I make a left turn and go 1, and my new point is right here. So let's get my purple. Here is my B prime. And a way to check that only works with 180 degree rotations is you should be able to draw from your new point to your center point and right through it to B. It should be on a line. If you spin a point 180 degrees around, it should form a straight line. A to C to A prime, that's a straight line. Just something to double check after. Only works for 180 degrees. Okay, so let's walk through those steps written out. So I say the first thing, if you've got a set of instructions, is from your center point to the point you will rotate, create a pathway of horizontal and vertical moves. So in this example here, I said, here's my center. I'm going to point A. So my pathway was start facing east or right or however you want to do it. That's what's going to change. And then I say, okay, so go forward 3, turn right, and then go forward 2. Notice I'm only talking about forwards and turn. Okay? The next thing is, okay, so rotate your starting direction only, the set number of degrees. Okay, so going back up here, it said rotate 90 degrees. CCW is abbreviation for counterclockwise. CW would be clockwise. So counterclockwise 90 degrees. So if I go down here, I was starting facing right. That was my first. I said, okay, start facing east, start facing right. So I'm going to turn that 90 degrees counterclockwise. So instead of facing to the right, that's going to be, whoops, I meant to grab this arrow. It's going to be facing up, right? It was facing right, spin up. So counter against a clock, a quarter of a turn. It goes like that. So this ends up turning just like this up to here. Okay, so now my robot will start, instead of facing east, my robot will start facing, oh, and I didn't write it, it will start facing north. That's the only thing that's different. Right? Other than that, everything else is the same. We're still going to go forward 3, right turn, forward 2. Same directions. Forward 3, right turn, forward 2. Exact same directions. The only thing that's different is we're starting in a different direction. So now I'm starting facing up, but I still go forward, forward, right turn. I go forward, forward, right turn. Okay? So same set of directions. Okay? So here we can try it out, all right? So let's actually do some rotations here. You can just watch me go through these. So about point B, so point B will stay the same, so I'll just put a B prime there, okay? 180 degrees, so point A used to be up 1, 2, 3, 4, right turn 3. So it was a 4, 3, L with a right turn. So I'm going to spin it 180 degrees. Okay, so now I'm going to go 1, 2, 3, 4, right turn, 1, 2, 3. And there is A prime with a 4 first, a right turn, and then a 3. All right, then C was, let's say, just over 1, 2, 3, 4. That's it. So it used to be facing right, go forward 4. Now I 180 turn. I'm going left, 1, 2, 3, 4, and that's my entire set of directions. So C prime is there, and there's our shape. Okay, and again, you could always double check with just 180 degrees that forms a straight line from C to C prime, and from A to A prime forms a straight line passing through that center. That only works with 180 degrees. All right, so the next one says about point N, so N will stay the same, become N prime. I want to rotate 90 degrees counterclockwise, so against the clock. So this used to be 1, 2, 3, 4, right turn 1, so 4, 1. And I'm going to spin that not clockwise, which would end up here. I'm going to spin counterclockwise down here. So 1, 2, 3, 4, 1, so 4 and 1. Here is our new M prime. O was go up 1, 2, 3, 4, 5, left turn 1, so 5, 1. Spinning that against the clock, instead of up from 12, it goes back to 9. Then I go forward 1, 2, 3, 4, 5, and make a left turn 1. There's my O. Again, what I did there, just to visualize it another way, is I went up 5 over 1, and I took that L and I spun it a little, I spun it a little more, I spun it a little more, I spun it a little more, until I was a 90-degree turn. That's what I did. Okay, and it's still a 5 and a 1. And I just connect to my lines. There we go. All right, so now this point is totally outside the shape, so all 3 points have to go. So 90 degrees clockwise around this point. Okay, so I was 2, 1 this way. I'm going to spin it clockwise 90 degrees, so now I'm 2, 1 here. And I end up at R prime. Okay, S is, well, let's do Q first. So 1, 2, 3, 4, right turn 3. So 4, 3, I spin that to the right, and that L ends up 1, 2, 3, 4, 1, 2, 3. Here's our Q prime. Okay, again, I took an L like this, and I spun it this way until it looks like that. Okay, now S, let's do it in a different color because we're overlapping so much. So S, I'm going to say I'm starting to the right. 1, 2, 3. Make a right turn. 1, 2. So 3, right turn 2. Spinning that clockwise, I get 1, 2, 3, right turn 2. So I end up right here. So let's put that pink down. Here is our S. And we got. And another way to double check this is in the end, just see if your end shape ends up where it should be. So let's look. I'm going to take my little scissor thing. You can do this by actually moving your piece of paper. Okay. So I'm going to say, oh, I got to include my center of rotation to be able to move it that way. Okay. So I'm going to put my finger on that point and I'm going to spin this 90 degrees. Okay. So 90 degrees and there we go. Hey, it worked out. So there's where I started. And then I go spinning, 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 exactly 90 degrees, and it ends up looking like that, which is just what we got, okay? Perfect. Okay, one more. We got 270, so that's 3 90s clockwise around this point. So here's the point. So 3, 1 with a right turn. Now, spinning it clockwise 270 is the same as counterclockwise 90, but let's do what it says. So spinning up 90 would be like this. Spinning it another 90 would be like this. Spinning it 3/4 of the way around would now be like this. So here's 3 and 1. Okay, so here's my new point V prime. All right, I'm going to do the same thing. T is 4, 3. Oh, a lot of 4 3s. So now it would be 4, 3 spun around, 4, 3 spun around, keep sitting. So 4, right turn 3. Here's my T prime. And then W would be over 1, 2, 3, 4, 5, 6 left turn 1. So 6 left turn 1, that would be 6, 1 this way. We spin it more, 6, 1 this way. Spin it more, 6, 1 this way. So we get 1, 2, 3, 4, 5, 6 over 1. Here's my W prime. And again, you could double check by just putting your finger on the shape and rotating it. I just want to show you one last little trick here. Okay, that one last little trick is there is an option to just memorize. I personally despise, I loathe memorization tricks. I'd rather understand the why and be able to just do it by, using a method that universally works. This memorization trick only with an asterisk works when you're rotating around the origin. So if you're rotating around the origin, you could just memorize that, for a 90-degree turn, AB becomes, so we switch places, and the first thing becomes negative. So for example, if you're doing a 90-degree rotation, and this is counterclockwise, then the point 3, 5 would become the point switch them, 5, 3, and then the B would come negative. So 90-degree rotation would take 3, 5 to negative 5, 3. Now to me, that is not helpful. To some people, that is awesome. So if you want to run with that, great. And I'll even give you one extra thing. So that only works if you're rotating around the origin. However, we have a little fix. If you're rotating around a point other than the origin, a little fix is draw your own coordinate plane. So for example, if you wanted to rotate around that center point, yeah, technically it's 6, negative 10, but what you could do is you could say, well, let's just pretend that this, and you could do this, not just, you could use your own scratch paper, and this is actually the coordinate plane. So you could rename this point 1, 2. This point, this would be 1, 2, 3, 1, 2, 3. So this is actually like 3, 4, and this is actually like 3, negative 2. This is a little fix if you wanted to rotate around any point. So obviously these points are all in the negative, negative. They're in the third quadrant. So I mean, we're drawing our own scratch work, temporary new coordinate plane, and then we could use our trick. So this says 90 degrees clockwise. So 90 degrees clockwise, since this is all counterclockwise, 90-degree clockwise would be the same as 270 degrees. So we would use this one, okay? Because turning 3/4 this way is the same as turning 1/4 this way. So we're going to use this. So A and B will switch places, and the second one will become negative. Okay, that's our trick. So let's do it. So we will get 3, 4 will become 4, negative 3. 1, 2 will become 2, negative 1. And 3, negative 2 will become negative 2, negative 3. Okay, so let's draw this out. So 4, negative 3 on our new graph. So 1, 2, 3, 4, negative 3 would be right here. That was originally our Q, so it'll be Q prime. This was originally R. This was originally S. So here's our Q prime, our R prime, and our S prime. So that will be Q prime. 2, negative 1. 2, negative 1 is our R prime. And our S prime is negative 2, negative 3. So there's our little temporary, oops, that was S prime. That's our temporary little fix that you could use the memorization trick with any center of rotation. And just to double check, here's our 90 degrees clockwise, ends up, now I shrunk it a little, but let's try that again, being a little more accurate. There we go. So there's 90 degrees, started like that, rotates down to there. Perfect, okay? So I'm just gonna walk you through a couple IXL examples, but that's it for the lesson. I hope you enjoyed it. Stay with me while I switch over to some IXL. Okay, so here's some IXL practice. L7, L8, and L9 are all really good practice for this. L8 and L9 are more about actually moving accurate points. But what I want to walk you through, we just did a bunch of that. Instead, I want to walk you through some practice of just kind of ballpark sketches. So this says, look at this diagram. I'm going to get out my pen here. look at this diagram. Which diagram shows quadrilateral DEFG rotate 135 degrees around? Okay, so we got point F is going to stay where it's at. That's going to stay there. And then we're going to rotate 135 degrees counterclockwise. So I just think that's more than 90, less than 180. So counterclockwise against a clock. So this original is going to spin more than 90. So 90 would be this angle. A 180 would be this angle. So it's going to come off somewhere over here. So G is going to be, or G prime is going to be somewhere. Whoa! That counted as an answer. Okay, well, let's try that again. Okay, so looking at this diagram, we've got rotated around point H. Okay, so this one's staying the same. 90 degrees counterclockwise. So I think F is going to be rotated 90 degrees. So that means this line will be perpendicular. So somewhere right up here. Okay, G will also be rotated 90 degrees. So it'll be somewhere over here. And it stays just the same length, right? The original just gets swung over. And so you get something like this. So let's scroll down. So here we have G getting spun that far. Okay, that's more than 90 degrees. Oh, it counts as an answer when you draw on the picture. Harsh. Okay. Let's try this again. This is all a learning process, okay? So let's look at this original. About S, so S will stay the same. 45 degrees counterclockwise, so against the clock. Now, if it was rotated against the clock 90, we would have R being somewhere over here. But halfway in between 0 and 90 would be right over here. So R will stay the same distance away, but end up about a quarter of a turn. So here's going to be our R prime. Now, T prime will swing this way, but again, it won't swing all the way. That's a 90 degree angle. It'll be somewhere in the middle, so it'll be over here. So we get T prime. So it'll look something like this. Whoops. So that'll be our shape with our R prime here, S prime staying in place, T prime over there. Okay, so let's see. Scrolling. This was not a reflection around S because you can see S and S prime are in two different spots. So it didn't spin around S. So we can rule that one out. This one spun. Or no, this one didn't spin. This is actually a mirror image. They reflected it over a center line. So R went from being here to being over here. And U went from being here to being over, whoops, that was U. Went to being U prime. So it mirror imaged over the line. It didn't actually rotate. Okay. This one is a rotation, but it doesn't look like ours. This one got rotated, give or take a little less than, I mean, like, here's our center, S. Oops, why is it not drawing? That's weird. Okay, well, for some reason it's not drawing, but that looks like R spun around S, not quite 180, so maybe this is a 170 degree rotation. Whereas down here, that's exactly the drawing we expected. So this one. Okay, let's do one last one together. Oh, and this one we're rotating around the center of a side. So we're rotating around K. So K will stay the same. Everything else will swing. So 180 degrees counterclockwise. So not like a clock. So here would be T swinging 90. Here would be T swinging 180. So 120, somewhere in between, a little less than halfway. So T will be here, T prime. Okay, U, if it was swinging, would be 90 here, 180 here. So maybe U will be over here somewhere. Okay, so we get, here's our T to U prime. And then S will swing counterclockwise this way, right? 90, a little more. So right over here. So here's our S prime. So we get this shape. So T prime, kind of where S is, maybe a little shorter. S prime over to the right, and U prime up at top. Let's look. Okay, so looking at the first one, that's not rotated around K because K moved. I don't see quite, oh, I see. It's rotated like they took the triangle and rotated around like this point. So it did swing around, but it swung around a point outside the shape. It didn't spin around K. K should have stayed the same. So in this one, K stayed the same. T spun from about here to about here. So I don't know, that's like around 90, 80 degrees or something, but that's 80 degrees clockwise. That's very different than the angle they asked us for. This one, again, K didn't stay the same. This one's actually a reflection. They took the triangle and reflected it over this line. So T went over to here, this went over to here, this one went over here, and you got a mirror image that's symmetrical. Okay, and last one, that's exactly what we expected, just like our sketch, except much more beautiful. All right, I hope you enjoyed this video. As always, the notes will be below the video. Enjoy.